What's up everybody, welcome to the video. Today we got a special reaction. We're going to be reacting to a video from Mark Rober. If you don't know who he is, he's pretty much a NASA scientist who's, I think he's created like, or at least helped create some of the satellites that go up around Mars and shit like that. I think he also helped create some like rovers that went on Mars. But he's really smart at creating things. He makes all kinds of cool shit. Just a minute you're about to see a gigantic Nerf gun that he's created, and this video deals with the Nerf gun. Apparently he makes the world's smallest Nerf gun shoot an ant. Let's get right into it, shall we? Alright guys, so we're about to get right into this video, but as you can see, here's this gigantic Nerf gun he made. This is my first ever Nerf gun I ever had. Like, this one right here is the first Nerf gun I've ever had as a kid, so this is gonna be very interesting. So let's get right into it.
The world's largest Nerf gun. This is a normal Nerf gun. And for the past year, I've been making good use of my time by working on this, the world's smallest Nerf gun.
That is pretty small. Hold on, go back to comparison. Let me see what. Okay, so that's a normal gun.
I've been making good use of my time by working
Dude, how do you even shoot that shit? What the fuck?
on this, the world's smallest Nerf gun, where you can actually cock it back and fire a dart. And while this is now the current world's smallest Nerf gun, our goal for today is to break that record not once, not twice, but 3 times, shrinking it by
How? How do you even do that? There's no way.
a factor of 10 each time we move down. And if my math's correct, that means by the time we get here, you'll be able to fit 5 of them across the width of a single human hair. But before we can start breaking all these records, we need to talk about the first major problem we encountered just to get here. And it relates to the fundamental way a Nerf gun works. Because when you pull the gray cocking mechanism back, it brings this spring-loaded piston with it all the way back until it hooks in with this catch mechanism. Now we're loaded and ready to fire. So now when you pull the spring-loaded trigger back, it forces the catch mechanism back down, releasing the piston plunger, which quickly springs forward, forcing all the air in the chamber out. And since the lightweight foam dart just happens to be in the way, it goes along for the ride. And
wow, that's actually pretty cool, pretty clever way of making a Nerf gun. That's pretty sick. So, like, how does inside of a gun work? I'm just kidding. No, that's very interesting. That's a very clever way to shoot Nerf bullets. Airsoft guns are kind of like the same way, right? Because it's just air shooting it. That's very interesting. That's very cool.
if you actually take one apart, you'll find it's made from 87 parts, 13 springs, and 6 hinges. And so the first problem you faced if you're trying to shrink that down to human hair scale is it would be impossible to assemble those tiny mechanical springs and hinges. Which left us with the incredible challenge of trying to make our entire tiny functional Nerf gun out of only one single part with no springs. And as it turns out, there's only one place in the world that leads the research in creating really tiny bendable machines from a single part, and it also just happens to be where I got my undergrad degree in mechanical engineering, which meant it was time for me to head back to my alma mater, BYU, to visit some old friends, starting with one of my favorite professors, Dr. Howell. Hey. Good to see you, Doc.
So there's a place where they make super tiny objects? Like, what's the point of making super tiny objects? There's only one place in the world? That's interesting.
Dr. Howell? I'm trying to remember what grade I got in your class.
I looked it up this morning.
I'm guessing an A-.
Oh, man, that's right. Well,
wow.
If I disclose that, that's a violation of federal privacy.
For what it's worth, he teaches much better than he poker faces.
And who would have known that this bright, energetic student sitting in this class was going to become one of the most famous engineers in the world?
Not me. I'll tell you that much. Not me. And I say that with confidence,
That's awesome.
He was also able to locate my student ID. And the only thing more aggressive than those eyebrows...
Dude, that's so sick. This teacher's cool as fuck. This professor's badass. He's a really cool guy.
...was the decision to rock the double puka shell necklace for picture day. Our first stop was to finally meet in person with a group of BYU students I'd been working pretty closely with on this project for about a year. So today was all about a final meetup to see if this was a mission accomplished situation for us. And Jacob, who led the student team, summarized the second major issue we faced here.
The physics of scaling down is huge here. Friction and surface forces are multiplied exponentially.
Besides the difficulty of assembly I mentioned before, this was was the second reason we needed it to be made out of one part, to eliminate the exponential friction forces between moving parts at tiny scales. Our plan was to come up with a template design that was full size, and if that worked, we would just keep scaling that exact shape down. But what should that look like? For example, how do you even store energy to fire a dart with no mechanical springs?
Yeah.
Well, here was the first prototype, and while it's still more than one part, you can see the clever way the springs were replaced with a few new parts that stored energy by being flexible. In engineering, we call that a compliant mechanism, and I happen to know the world's foremost expert in that field. This is the book
Oh, that's
on compliant
badass.
mechanisms.
Oh, I think so, but I'm not. I may be biased.
And he's as humble as he is biased, because this is hands down the #1 cited book in this field.
A regular
Damn, his professor wrote the #1 book on that. Dude, this guy is smart as hell. So they're not gonna use air, they're gonna use like a mechanical like bending system, I guess, to shoot it.
mechanism is going to have rigid links, and something like hinges are going to make it move something like this.
Oh
And this is a
wow.
very common type of mechanism called a 4-bar linkage, and Dr. Howe explained how you can make that out of only one part.
We get our motion from something that bends, flexes.
Oh wow.
And this is a great demo because if you overlay them on top of each other, you can see the resulting motion is totally identical.
And that is compliant because it's flexible, and that is a compliant mechanism.
And as Dr. Howell went on to explain, the compliant mechanism version offers 6 advantages. Number 1, it's fewer parts. In this case, 8 versus 1. Number 2,
Wow.
lower cost. There's no labor for assembly, and the whole thing can be made in one process, like 3D printing in this case. 3, it's more precise. It always returns back to the exact same spot, and there's no slop between different parts, like the hole in the hinge. 4, lower weight. This is crucial for space applications. 5, no friction between parts. That means no wear between moving parts and no need for lubrication. And finally, number 6, you got built-in springs. Every material has built-in springiness, so the shape we choose can cleverly take advantage of that. He then proceeded.
Dude, that is very clever. So it just matters about what material you have and like how you print it out. So like, cause the material needs to be super bendy. It has to be super bendy so it can like fire back. That's so clever. So cool. What is this?
They did show me some other mind-bending examples of compliant mechanisms, like this single-part light switch, or this single piece of metal bending in
What?
ways it feels metal shouldn't be allowed to bend, or this single sheet of plastic cut in such a way where it's really flexible in one direction,
Oh,
but really
shit.
stiff and unbendable in the other. They've commercialized some
That's
compliant mechanisms
badass.
like this one-piece windshield wiper for surgical cameras, so doctors can use one hand and clean the lens like this, instead of constantly pulling it out and doing this. And they
Oh,
even did some work
wow.
for NASA, where you can get a thruster to point in any direction using a single titanium structure that bends and just 2 motor inputs.
Oh,
and so back to our
shit.
Nerf gun,
That's
after
so
many,
sick.
many more prototypes, investigating countless different ways to store the energy.
Dude, that guy has to be like a multi-billionaire, bro. Designing shit that goes in NASA spaceships like that. That's so clever. So weird how like they find these ways to bend shit and all that, and it helps us in ways that I never even thought.
We landed at 3 final candidate designs, all of which achieved our primary design objective.
There's no assembly, it's just all printed as one part.
The first design
No
was
way.
a zigzag and looked really cool, but the flexures didn't store that much energy per deflection because they're just in bending. The second design was a fishbone, and it was better at storing energy using a combination of compression and bending, but the
Ooh.
bending ribs weren't very long, and longer ribs will lead to more power. And so for the third and final design, Jacob accommodated longer ribs by offsetting the backbone, so to speak.
Ooh.
And this ended up being the most optimal design. And if we swap out the plastic with a metallic alloy, it can
That's
store more
sick.
energy per the same deflection, which means it can fire a dart even more powerful than an ordinary pneumatic Nerf gun. Plus, it sounds
wow.
really cool. And now that we
That's
settled
sick.
on our template design, darn it, that was almost cool. It was time to set our first world record by shrinking
That's
the
so
template
awesome.
down 10 times smaller.
That's so sick how they found a way to shoot a bullet without even using parts. The military's gonna love watching this video and trying to figure it out.
This is 3D printed
crazy.
using an SLA printer.
And what's cool about this relatively new process of 3D microprinting is that you can achieve orders of magnitude finer resolution than your typical PLA printer at home, which is
What
why
the
I was
fuck?
so stoked to finally try and fire it for the first time.
So this is actually a little 3D bullet.
Oh my gosh, yeah, you can like put it right there in the chamber? No way. Okay,
Whoa.
ready? When you cock it back, you see the flexures are in fact bending, storing the energy just like at the full-scale template.
That's so sick.
So satisfying. Okay, loading? Yes. Okay, here you go.
Hey.
That was amazing. It fires the dart around 3 feet, which is really interesting because that's also a factor of 10 scale down from how far a normal Nerf dart fires. All right, Bethany, it's only appropriate
Wow.
we have a Nerf blaster accuracy contest. There's a penny out here. Closest to the penny wins. Are you ready?
Like 6 inches.
3,
That's so cool.
2. Oh man, mine went so far. And while mine did shoot further, Bethany was closer to the penny, so she earned the W. New world record, world's smallest Nerf fight. And by the way, we're making
Wow.
all the CAD files we
That's so sick. But it's shitty firing. Like that's not really accurate, and the bullet kind of like flops over and all that. But still pretty cool.
used available on Thingiverse for free, so you can have your own 3D printed Nerf battle at home. I'll leave
No
a link in
way.
the video description. There's even some designs there that are Lego compatible, so you can get real clever and design your very own compliant mechanism. Now it's time to shrink down to
wow.
100 times smaller than a normal Nerf gun over in the Micro Mechanisms lab. But before we did that,
Okay.
I asked to make a quick detour for a very specific reason. This is where I
What?
lived freshman year.
Oh no way.
It was the smell more than anything that really brought back the nostalgia. It smells like a bunch of 19-year-olds with questionable hygiene. This is my room,
Damn.
3204. Lucky for me, they were between semesters, so I could have full access to the room to get right down to business. I invented a way to break into other dorm rooms in like 1.4 seconds
No
when
way.
we were here. And when I left, I hid it in this air vent. So we're gonna see if it's still there.
Oh shit. No way. That's so cool. And bro, college dorms do smell like shit. When I went on a church camp at a college campus, we had to like help clean up the dorms, like our mess afterwards, and some of the other buildings. And our church, we got really nice college dorms, but some of the churches, I guess, who didn't have much money, they had to get the shadier dorms. Dude, tons of cockroaches, smelled like rotten eggs. It was terrible.
Well, it's not there, which means there's only one option. We gotta make a new one. So to make one, you just start with the roll of duct, wax dental floss, brush off the unused uranium, you should be good. Still remember after all these years. Locked. Now I want to stress, this is for emergency use only. Like if you want to play Mario Kart in Scott Glacier's dorm and he's not home. I still got it. And so with mischief managed, it was back to work.
No way, what the fuck?
That is minuscule. And at this
That's insane how you, okay, that's insane. But how do you fucking unlock the door? Are you gonna talk about that shit? What the fuck?
size, we had to use a microscope to see what was going on. Can we fire this thing?
Absolutely.
And on top of that, there's no possible way I would have the dexterity to load it up with tweezers, so we used a micro manipulator instead, where each turn of these knobs will move the needle probe fractions of a millimeter
Wow.
in any one of 3 directions.
All right, now continue going down.
Oh my gosh. And it feels a little bit like defusing a bomb because you have to be so incredibly
No fucking
careful
way.
since the slightest turn of a knob in the wrong direction.
Oh no.
Oh no. Can immediately destroy the delicate carbon nanotubes. Which reminds
Oh,
me,
shit.
I forgot to mention this version of the Nerf gun is actually grown from carbon nanotubes because there just aren't many
What the
other
fuck?
ways to make something this small and precise. It's a 2-step process Bridget walked me through where you start in a clean room and use photolithography to create a pattern on a silicone wafer very similar to the process of making microchips. Then for step 2, using the wafer as a mask, you get a thin layer of iron in the spots where you want the tubes to grow. Then you put it in a furnace and then blow very specific gases over it at very hot temperatures.
What?
The whole process only takes about 8 hours, but when you're done, you're left with incredibly precise, tiny little structures. Don't screw this up, Mark. The smallest part.
Dude, who came up with that shit? Who just said, oh, guys, I know how to make microscopic pieces of plastic and metals. And this is how you do it. Like, that's so impressive. That's so cool. Like, the way we got to that point, that's so cool.
Firing of a Nerf gun ever in 3, 2, 1. It's gone! Well done, team! It's kind of like
Wow.
it's there, and then it's not there. There's just something so satisfying about seeing a compliant mechanism design still function just as
Wow,
well,
that
even
thing
when it's 100
shoots.
times smaller than the original. With that out of the way, all that was left was to challenge an ant to a Nerf battle. This is
No
actually
way.
like a perfect scale for an ant. And I actually tried to start some beef here by firing a dart his way, but he was seemingly unintimidated. Hey, get back here.
Damn.
Wow! Oh, he took it! Okay, he was
That's
definitely
cool.
unintimidated. He took my gun! Now you guys made one an order of magnitude.
Wow, those things are actually smaller than ants, bro. The ants can pick it up and fire at each other.
Smaller than this, right?
Yeah, 1/10 that size.
Whoa. But before we get to that, you should know that the water
No
fight equivalent
way.
to the world's largest Nerf gun is the world's largest Super Soaker. And sadly, you can no longer buy normal Super Soakers, but we've designed something that's better for 2 reasons. Number 1, you get to put it together yourself so you actually understand and see how
Oh,
it works.
shit,
And
that's
number
cool.
2, there's a secret prank built in because after you spray your brother, you do the right thing and give him a free shot in return. But before you pass it over, you discreetly turn this valve. Then you watch him self-own. And then
Oh,
you
that's
rest.
sick.
And if you want to experience this toy for yourself, then you're gonna have to get a Crunch Labs Build Box subscription, where you get a super fun toy every month, which comes with a video where I teach you all the juicy physics that make the toy
Oh,
work.
wow.
So if you want to have a ton of fun while learning to think and prank like an engineer, visit crunchlabs.com to
Oh.
learn more. Back.
Dude, that's so sick. That's so cool. I like that. And Mr. Beast is in there. I gotta see if Mr. Beast is in there, but I'm just playing. Oh, that's so cool, bro. If I was a kid, I would be buying that shit all day. I might actually get myself. I don't even need to be. I might just get myself just to see how to build cool things, man.
To breaking world records, it was once again time to shrink down by a factor of 10, which makes this spec right here 1,000 times smaller than a normal Nerf gun. Whoa. And so in order to truly appreciate the proper scale here, I had to make a sacrifice.
No
Got
way.
one. Oh, wow.
What?
Look at that.
No way.
Now, admittedly, these are just the outline without the internal compliant mechanism. In part because even if it were there, it's just too small, so we'd have no way to actually cock it back and pull the trigger. And so for the 4th and final world record, it was time to shrink down one last time by a factor of 10 to land us at 10,000 times smaller
No
than a normal
way.
Nerf gun.
So, but you can't fire them at all? That's insane. You can't even fire the guns. Yo, this is the world's smallest Nerf gun. You can give me a camera view. Hold on. Here, get like right here. Look, that's the world's smallest bullet.
Now I just had to find it. And is that on here as well?
Look.
Yep, just scroll up.
No.
That's his hair. And like right here, see that right there? I'm pointing at? That's another gun. They 3D printed that.
Wow.
That's tiny. They can print that tiny.
That's insane. I
Yeah.
didn't know they could do that.
I mean, neither. Yep.
5 of those would fit across one
That's
lane.
insane. That's one of the smallest guns I've ever seen in my
And at
life.
this point, we had to upgrade to their Electron microscope to properly appreciate the scale here as Ivy walked me through the resulting images.
That's so awesome.
That's a cool shot. And
That's
that's
so
a human
awesome.
hair there, but to even appreciate how small a human hair is, we found a dead ant outside, and you can see at this
Oh.
scale, it looks like a giant alien monster by
Whoa,
comparison.
yeah, it
I also
does.
found it fascinating to see what the carbon nanotubes actually look like when you zoom in this much. And so without the aid of an electron microscope,
so
that
crazy.
final world record Nerf gun is an imperceptible speck a fifth the width of my hair right here. And that's insanely tiny.
That's
But in
insanely
an effort
tiny.
to do a better job at protecting this record for my buddy Mr. Beast,
That's so sad. Protecting this record. Yeah, I don't know even how you get smaller than that. Smaller than a piece of your hair? I don't know how you get tinier than that.
I knew I had to go even smaller. And not just an additional 10 or 20 times smaller. We're talking 300 times smaller. That makes it
How?
3 million times smaller
How do you even make a gun smaller than that? What the
than a normal
fuck?
Nerf gun. It's so small, in fact, that a single drop of liquid like this could contain trillions of them. And I know what you're thinking.
Yeah.
Mark, that's crazy. I mean, at that
That's
scale,
so
you
crazy.
basically need to fold a DNA helix into the shape of a Nerf gun. Which was precisely our plan. And to pull it off, I need to head down to the Salk Institute in
What
San
the
Diego,
fuck?
California.
Why do people... But, like, what do you need this for? And why does this place have a fucking pool. Like, do scientists like live there? If they do and they have like pool parties and shit, that's so sick.
Yeah. Now, Salk is a non-profit biological research institute founded by Jonas Salk. And my favorite thing about him is not necessarily that he discovered the cure for polio, but that after doing so, he decided to forgo the $3 billion he would have made by patenting the vaccine, and instead made the cure available for free to everyone. And that attitude of altruistic scientific curiosity permeates the Institute still today, creating an environment for discoveries like the helical structure of the DNA molecule.
That's awesome.
Which just so happens to be the exact reason we were here.
The technology we work with is
so
DNA
awesome.
origami.
Yeah.
We use DNA slightly differently from how it's used in biology.
This, by the way, is Pallav. He's a genius who runs his own lab here, and his passion about everything and anything biological is contagious.
I mean, don't get me started on bacteriophages. There is a side.
Pallav explained that if you want to build a house, you first need a blueprint that has all the specific instructions for how to build the house. And the equivalent of a house blueprint in nature is called DNA. Every single cell in your body has DNA that looks like this, with a complete set of instructions on how to build you. And that's DNA's only job in nature. But some of Pallav's predecessors asked an interesting question.
What if you use the DNA itself
Yeah.
as the building material?
So instead of using DNA just as the blueprint to give information to build something else, what if you effectively use that blueprint as a sheet of origami, telling you where to cut and fold, so the blueprint itself becomes a tiny little structure? And here's how they actually do that.
So if you think of DNA, right,
What?
it's two strands,
Yeah.
and they're usually complementary. So if you have an A here, you have a T here. If you have a C here, you have a G here.
Right.
And then when they come together, they kind of zip up. A binds with T, and C binds with G, and so forth, right?
Got it.
So if you have two complementary
Okay, not trying to cut him off. I know we're on to something here. But I learned this in biology. This is pretty cool. But you're telling me that they're going to use DNA and, like, they can just... We definitely have cloning. Cloning is definitely a thing. We invented clones. There's no way we haven't at this point.
strands, they will zip up and form this familiar double helix structure. But what if they weren't completely complementary?
Okay.
What if, like, this part here was complementary to this part here, but then this part here was not complementary to this? But then you have these two flimsy parts that haven't paired up yet.
Right.
So now if you introduce a third part, for instance, that binds to these unbound parts, you can create junctions, right? And those junctions, you can then branch them out and build them further into larger structures.
So using that
What the
principle, they
fuck?
start with a naturally occurring single-stranded DNA they call the scaffold strand, and on a computer, they design out the shape they want. Now as it stands here, there's nothing attached to the other side, so it would just lose its shape. But if you add in a bunch of what they call staple strands of DNA that are specifically designed to match the corresponding sections on the scaffold strand, they effectively lock it into the desired shape. So in theory, if you just put a random scaffold strand and then all the corresponding custom-made staple strands in a solution together at the right temperature, and then let it sit for a while, it would automatically self-assemble into an infinitesimally small Nerf gun made strictly from DNA. No.
What the fuck? Bro, this dude looks like he cracked. He just looks cracked out, bro. That brain has so much information. Like, what is all this shit? What the fuck? Action items from LSD on Wyandotte? Dude, I don't know what this guy, like, what any of this shit's about. Like, what the fuck is that about? Okay, anyways, I'm distracted.
No way. But since you can't set a world record with just a theory, it was time to make some Nerf guns. So with a little help from Lauren and Amanda on Pauline's team, we got right to work. Step one was to take a solution containing trillions of
wild.
scaffolding strands of DNA, and then mix in another solution containing quadrillions of the staple strands of DNA. Then we place that magical mix into 8 individual tubes, and then place them in a special oven that would maintain the ideal
But where do you get DNA from? Like, how do you pull out DNA? That's what I'm wondering. This is all insane to me.
temperature for the self-assembly process to occur, and we set a timer.
We're so
we
far
just come back
ahead.
in an hour and 20 minutes?
Yeah.
So easy. And I feel like I should pretend the whole process was harder than that.
Ready to eat?
Like how do you even remember this shit?
Eat, yeah.
But when the timer was up, that was basically it. So after a quick final process of using an electric field to separate the successfully merged guns from all the strands that didn't successfully merge, you're left with a few drops of water containing 1.2 trillion of the
Wow.
world's smallest Nerf guns.
No
The final step,
way.
we just needed to prove to ourselves that they were actually in there. And that's where Jocelyn comes in. We need help, Jocelyn. I'm told you are the person to make these seeable.
I can help with that, although there's no label on it.
And what's wild
Damn.
here is it's beyond the realm of physics to build a typical microscope powerful enough to see these. Because
Yeah, so okay, what I'm wondering is how do you become smart enough? Like how much money do these people make? Seriously. Like they better all be driving Lamborghinis, bro. This is impressive as shit.
our Nerf guns are 100 nanometers in length, which is 5 times smaller than the actual wavelength of visible light. So Jocelyn's using an atomic force microscope instead, where there's a super tiny probe that just drags back and forth on a surface. And when it encounters anything as small as a single atom, it raises the probe up, and that deflection is measured using a laser. So if you drag that tiny probe back and forth enough, you sort of feel your way to revealing what can't be seen. So after a little
That's
while, Jocelyn
insane.
returned, allowing me to now present
No
to you
way.
a small sampling of the world's officially smallest Nerf guns,
No
made
fucking
entirely just of DNA.
Wow.
Pretty freaking good.
Wow.
And what blows my mind is that each of these is made from just a few thousand atoms. To comprehend just how small that is,
Still
if you
doesn't
link
make
them end
sense.
to end,
It still doesn't make sense to me, like how like they told the DNA to make this. Like how did the DNA know to do this? Like did they piece them together? Like what? Like, what math is this?
and it would take 2,000 to fit across a single human hair. Your move, Mr. Beast. So as I closed out my visit, Pallav let me know about how this project had sparked some ideas for his team.
If we can make specific Nerf blasters, or whatever you want to call them, DNA injection devices, and we can target particular kinds of cells, then we can make much more targeted treatments for a range of diseases. But in all of these therapies, you need to deliver the correct DNA. So how do you get those into the cells?
Nerf blaster.
Nerf blaster.
Okay, so this is really just the beginning. In a couple of years, we're going to come back to the sequel to this video. Does that
That's
make me a
insane.
co-author on this paper?
Well, you definitely co-author on the paper.
Okay.
Wow.
I don't know on the Nobel Prize.
And as I closed out the trip, I couldn't help but feel a little
Wow,
extra
he really
glimmer of
wants
hope
to get
for us
Nobel
humans.
Prize, too.
Because by giving them an admittedly ridiculous challenge, I got a tiny glimpse of the cutting-edge research happening at both BYU and the Salk Institute. And while a Nerf gun by itself won't do much to help humanity, it was a small reminder that millions upon millions of engineers and scientists in labs all around the world are dreaming up the big ideas, working hard right now to improve the lives of future generations by solving some of the toughest problems of our time. It's a sentiment possibly summed up
That's
best
awesome.
by Jonas Salk himself. Hope lies in dreams, in imagination, and in the courage of those who dare to make dreams into reality. What I love most
Wow,
about people
that's
like
so
Jonas
sick. That's
Salk
awesome.
and Pallav is the creative confidence they exude as they approach the tough problems. It's an attitude that can be learned, and it's why the goal of every Crunch Labs build box is to help you think like an engineer. But the learning doesn't feel like learning, because every month you're having tons of fun with a really cool toy that you put together yourself. We learn all the physics behind what's going on while building your creative confidence along the way.
It worked!
And since the holidays are coming up, there's nothing more fun to put on your list, nor is there a better gift to give than an investment in the future of the favorite young person in your life as you watch their confidence and resilience grow. And possibly the coolest part of all is each month we randomly select one box to slip in a platinum ticket. And if it happens to be yours, then you're coming out right here to Crunch Labs to design with me and my team for a day. So if you want to unlock the superpower
That's
of learning how
awesome.
to create and build whatever you can dream up, even if it's really, really small, just head to crunchlabs.com or use the link in the video description to learn more. Thanks for watching.
Hell yeah, bro. That was a sick video. That's so badass. Yo, that just shows y'all. That just shows y'all. Y'all gotta dream, bro. You gotta dream big, dream hard, because, like, anything can happen. That just showed me right there, like, you can do anything you want. You can put anything you put your mind to, because I've never seen anything like that in my life before. I've never seen anything so cool. Like, that was probably the coolest thing I've ever seen in my life. I still don't understand who came up with this shit and how and, like, what the process was. It makes me want to watch a whole documentary or read a book or something on how somebody even came up with it. burping, but I hope y'all have an amazing night. I hope you have an amazing day. Please leave a like. Please subscribe. This channel is gonna go crazy, bro. If someone can do that, I can make this big channel go crazy. So, but please help out. Please leave a like. Please subscribe. Good night and peace.